Hello, this is Sirisha Kisara coming to icp4. Here we are doing the machine learning algorithm, learning the machine learning algorithms with Python. So coming to the first part, finding the correlation between the survived and sex column in the data set provided here. So in the source code we have a data set. So using the trained data set in the source code, I'll find the correlation between the survive ID and sex. So going to the code, here I have imported pandas, which is a open source library for high performance and easy to use data structures and data analysis tools for the Python. And I also imported pathlib, where it handles the in Python there is always a path handling problem. So it resolves that. It goes to the directory and searches where this CSV or whatever the file name that we give exists, and it reads it. So we can use path for that. So here I'm taking the train.csv from the source code, which has the survive ID and sex. So here I'm reading the file using read CSV with the help of pandas, and using this here I've read the CSV file. Using that, I'm taking the two parameters sex and survive ID, two columns, and grouping them by sex. Like we have only two main male and female, if you see. So I'm grouping them by sex and sorting the values and finding the mean of them and printing it. Let me run this code. So here if you see the correlation to the survey ID, percentage mean is, so coming to the percentage, it will be 74% female and 18% male. So the correlation between the female and the survive ID is more. And next part in the icp4 is like implementing the naive-Bayes method. A naive-Bayes method is a supervised learning method which is used for classification, regression, etc. using scikit-learn library of Python. So this is the dataset we are using. Going to the code. So I've imported pandas and sklearn, from which I can use different functions in Python, and I also imported Gaussian NB from naive-Bayes, which is mainly used for classification. So here I'm reading this glass.csv file, which has some data. So after reading, and I'm saving the data into a variable y, and here I'm saving the data into a variable df, and saving the column type of type into y. So in this type, apart from the type, the remaining I'm saying I'm dropping the column type, and remaining data I'm saving it into df1. And using the Gaussian NB, I'll classify them, and using this model I'm giving the X train and Y train, and predicting the test score of this model. I'm predicting the total accuracy. So whenever I run this naive, so let me run this code to see the accuracy of the test data of the data set that we have given. So the accuracy we got is 51.52. With the SVM, which is another supervised learning method to test the accuracy of the data set. So here I'm using the linear SVM, so for which we have classes SVC. There are different other classes in the SVM supervised learning methods. So I'm training the data with X-train and Y-train, and I'm testing the data, predicting the score with the X test. Let me run this code. As you can see, the accuracy is 68.18, which is a little better than naive Bayes. And the next part is using SVM with RBF kernel, where I'll pass this RBF in the SVC class. The kernel will be RBF, the remaining will be same, and I'll load the class.csv and read it with pandas. Store it in a variable. I'll get the type, column, delete it, drop it from the data set, and train the model with the train data and test the model with the text data and predict the accuracy for the text data, test data. Let me run this code. So we got an accuracy of 69, which is a little better than the previous 68, and it is 69. That's it. Thank you.